Today I want to talk about domain number 4 out of the CISSP exam. Domain number 4, communication and network security, covers various topics such as how to assess and implement secure designs in network architectures. That covers various topics such as the OSI model and the TCP/IP model, as well as secure protocols. It covers wireless networks, Wi-Fi networks, Zigbee, and satellite networks. It also covers cellular networks such as 4G and 5G, as well as content distribution networks. I want you to tap all the way in for this one. It's a deep topic. We're going from 0 to 100 on this one. Hacker Black, CISSP, Domain 4, Communication and Network Security. Tap in.
Domain 4. Communication and Network Security. Domain Objectives. Name the layers of the Open Systems Interconnection, OSI, and Transport Control Protocol/Internet Protocol, TCP/IP network models. Compare the differences and similarities between the Open Systems Interconnection, OSI, and Transport Control Protocol/Internet Protocol, TCP/IP network models. List the concepts and architecture that define the associated technology and implementation systems and protocols at Open Systems Interconnection, OSI, model layers 1 to 7. Define related threats and select appropriate countermeasures for systems and protocols operating at Open Systems Interconnection, OSI, model layers 1 to 7. Identify technological implementations that provide services to support mobility and collaboration. Describe various network services that abstract and virtualize underlying components and infrastructure and associate service benefits. Recognize relevant network components used to secure communications and differentiate use based upon requirements. Demonstrate use of secure network components as countermeasures in response to specific threats associated with the Open Systems Interconnection, OSI, model layers 1 to 7. Define secure communications channels that support remote access services and collaboration. Secure design principles in network architectures. OSI Layer 1, Physical Layer. OSI Layer 2, Data Link Layer. OSI Layer 3, Network Layer. OSI Layer 4, Transport Layer. OSI Layer 5, Session Layer. Domain Agenda, Continued. OSI Layer 6, Presentation Layer. OSI Layer 7, Application Layer. Service Considerations. Secure Network Components. Secure Communication Channels according to Design Domain Review. Module 1. Secure Design Principles in Network Architectures. Module Objectives. Name the layers of the Open Systems Interconnection, OSI, and Transport Control Protocol/Internet Protocol, TCP/IP network models. Compare the differences and similarities between the Open Systems Interconnection, OSI, and Transport Control Protocol/Internet Protocol, TCP/IP network models. Architecture and Design. ISO IEC 7498 consists of the following parts. Part 1, the basic model. Part 2, security architecture. Part 3, naming and addressing. Part 4, management framework. Open Systems Interconnection, OSI model. Packets. Network. Path determination and IP, logical addressing. Frames. Data link. MAC and LLC, physical addressing. Bits. Physical. Media, signal, and binary transmission. TCP/IP model compared to OSI model. Module 2. OSI Layer 1, Physical Layer. Module Objectives. List the concepts and architecture that define the associated technology and implementation systems and protocols at Open Systems Interconnection, OSI, model layers 1 to 7. Physical layer. Define related threats and select appropriate countermeasures for systems and protocols operating at Open Systems Interconnection, OSI, model layers 1 to 7. Physical layer. Concepts and architecture. OSI Layer 1, Physical Layer. Bits are encoded and decoded. Signals include light, radio, and electrical. Baseband or broadband. Network topologies. Bus. Tree. Ring. Mesh. Star. Carrier Sense Multiple Access, CSMA. Carrier Sense Multiple Access with Collision Detection, CSMA/CD Wired Technology. Carrier Sense Multiple Access with Collision Avoidance, CSMA/CA Wireless Technology. Wired, LAN/WAN concentrators, multiplexers, hubs, and repeaters. Token Ring, IEEE 802.5 Fiber Distributed Data Interface, FDDI Twisted Pair. Coaxial cable. Fiber optic. Wired, Internet Digital Subscriber Lines, DSLs. Asymmetric Digital Subscriber Line, ADSL. Rate Adaptive DSL, RADSL. Symmetric Digital Subscriber Line, SDSL. Very High Bit Rate DSL, VDSL. Wired, Internet Cable Modem. Wired, Internet Broadband over Power Line, VPL. Broadband over Med. Low electrical power. Speeds comparable to DSL. Significant potential improbable implementation. Wireless, LAN/WAN Wi-Fi, Wireless LAN IEEE 802.11x Bluetooth, Wireless Personal Area Network IEEE 802.15 WiMAX, Broadband Wireless Access IEEE 802.16 Satellite. Wireless, Cellular Code Division Multiple Access, CDMA Global System for Mobiles, GSM. Threats and Countermeasures. Physical Layer Technology. Unshielded Twisted Pair, UTP Shielded Twisted Pair, STP Coaxial Cable. Cellular. Fiber Optic Cable. Bus Topology. Ring Topology. Mesh Topology. Bluetooth. Note, please refer to Table 4.2 on pages 351 and 352 in the Student Guide. Module 3. OSI Layer 2, Data Link Layer. Module Objectives. List the concepts and architecture that define the associated technology and implementation systems and protocols at Open Systems Interconnection, OSI, Model Layers 1 to 7. Data Link Layer. Define related threats and select appropriate countermeasures for systems and protocols operating at Open Systems Interconnection, OSI, Model Layers 1 to 7. Data Link Layer. Concepts and architecture. Open Systems Interconnection, OSI, Layer 2, Data Link Layer. Transmits data as frames. Media Access Control, MAC Layer. Logical Link Control, LLC Layer. Technology and Implementation. Protocols. Address Resolution Protocol, ARP. Fiber Channel over Ethernet, FO Multi-Protocol Label Switching, MPLS. Technology and Implementation, Continued. Devices. Bridges. Switches. Virtual Local Area Networks, VLANs. Threats and Countermeasures. Data Link Layer Technology. VLAN. Address Resolution Protocol, ARP Multicast. Spanning Tree Protocol. Note, please refer to Table 4.3 on page 358 in the Student Guide. Module 4. OSI Layer 3, Network Layer. Module Objectives. List the concepts and architecture that define the associated technology and implementation systems and protocols at Open Systems Interconnection, OSI, Model Layers 1 to 7. Network Layer. Define related threats and select appropriate countermeasures for systems and protocols operating at Open Systems Interconnection, OSI, Model Layers 1 to 7. Network Layer. Concepts and architecture. OSI Layer 3, Network Layer. Transmits packets by logical address schemes. Unicast. Multicast. Broadcast. Technology and Implementation. Protocols. Internet Protocol, IP4/Internet Protocol, IP6 Internet Control Message Protocol, ICMP Internet Group Management Protocol, IGMP Open Shortest Path First, OSPF. Technology and Implementation, Continued. Devices. Routers. Firewalls. Next Generation Firewalls, NGFWs. Threats and Countermeasures. Network Layer Technology. Firewall. Router. ICMP IP Fragmentation. Note, please refer to Table 4.4 on page 364 in the Student Guide. Module 5. OSI Layer 4, Transport Layer. Module Objectives. List the concepts and architecture that define the associated technology and implementation systems and protocols at Open Systems Interconnection, OSI, Model Layers 1 to 7. Transport Layer. Define related threats and select appropriate countermeasures for systems and protocols operating at Open Systems Interconnection, OSI, Model Layers 1 to 7. Transport Layer. Concepts and architecture. OSI Layer 4, Transport Layer. Transmits segments with end-to-end service delivery. Addresses quality of service, COS needs. Technology and implementation. Protocols. Transmission Control Protocol, TCP User Datagram Protocol, UDP. Well-known ports, port 0 to 1023. Registered ports, ports 1024 to 49151. Dynamic or private ports, ports 49,152 to 65,535. Threats and countermeasures. Transport layer technology. Transport Control Protocol, TCP, connection. UDP broadcast. Note, please refer to Table 4.5 on page 367 in the student guide. Module 6. OSI Layer 5, Session Layer. Module Objectives. List the concepts and architecture that define the associated technology and implementation systems and protocols at Open Systems Interconnection, OSI, Model Layers 1 to 7. Session Layer define related threats and select appropriate countermeasures for systems and protocols operating at Open Systems Interconnection, OSI, Model Layers 1 to 7. Session Layer. Concepts and architecture. OSI Layer 5, Session Layer. Maintains persistent connections between hosts. Creates and tiers down sessions. Technology and implementation. Protocols. PAP, Password Authentication Protocol. PPTP, Point-to-Point Tunneling Protocol. RPC, Remote Procedure Call Protocol. Threats and countermeasures. Session Layer. ISO 7498-2 specifies that no security services are provided in the session layer. Secure risky protocols that are still needed by means of encryption. Module 7. OSI Layer 6, Presentation Layer. Module Objectives. List the concepts and architecture that define the associated technology and implementation systems and protocols at Open Systems Interconnection, OSI, Model Layers 1 to 7. Presentation Layer define related threats and select appropriate countermeasures for systems and protocols operating at Open Systems Interconnection, OSI, Model Layers 1 to 7. Presentation Layer. Concepts and architecture. OSI Layer 6, Presentation Layer. Manages common encoding methods that include ASCII, EBCDIC, Unicode, UTF-8. Technology and implementation. Not only are people using UTF-8 for their pages, but Unicode encodings are the basis of the web itself. All browsers use Unicode internally and convert all other encodings to Unicode for processing. As do all search engines. All modern operating systems also use Unicode internally. It has become part of the fabric of the web. W3C. Threats and countermeasures. Presentation Layer Technology. Unicode. Note, please refer to Table 4.6 on page 372 in the student guide. Module 8. OSI Layer 7, Application Layer. Module Objectives. List the concepts and architecture that define the associated technology and implementation systems and protocols at Open Systems Interconnection, OSI, Model Layers 1 to 7. Application Layer define related threats and select appropriate countermeasures for systems and protocols operating at Open Systems Interconnection, OSI, Model Layers 1 to 7. Application Layer. Concepts and architecture. OSI Layer 7, Presentation Layer. Network-based application communication. Human-supported messaging and systems control. Technology and implementation. Protocols. Dynamic Host Configuration Protocol, DHCP/DHCPv6 Domain Name System, DNS Simple Network Management Protocol, SNMP Lightweight Directory Access Protocol, LDAP Hypertext Transfer Protocol, HTTP. Threats and countermeasures. Application Layer Technology. DHCP. DNS. HTTP. LAP. SNMP. Note, please refer to Table 4.7 on page 377 in the student guide. Module 9. Service Considerations. Module Objectives. Identify technological implementations that provide services to support mobility and collaboration. Describe various network services that abstract and virtualize underlying components and infrastructure and associate service benefits. Mobility and collaboration. Remote meeting technology. Structure. Setup. Vulnerabilities. Virtualized networks. Permanent virtual circuits, PVC switched virtual circuits, SVC circuit switched networks. Packet switched networks. Software-defined network, SDN, is defined by 3 separate planes or layers. Application layer. Control layer. Infrastructure layer. Software-defined wide area network, SD-WAN. Content distribution networks, CDNs origin servers. Edge servers. Module 10. Secure network components. Module objectives. Recognize relevant network components used to secure communications and differentiate use based upon requirements. Demonstrate use of secure network components as countermeasures in response to specific threats associated with the Open Systems Interconnection, OSI, model layers 1 to 7. Firewalls. Static packet filtering. Stateful inspection and dynamic packet filtering. Next-generation firewalls, NGFWs. Intrusion detection and prevention systems, IDS/IPS host-based intrusion detection system, HIDS network-based intrusion detection system, NIDS host-based intrusion prevention system, HIPS network-based intrusion prevention system, NIPS signature or pattern matching systems. Protocol anomaly-based systems. Statistical anomaly-based systems. Whitelisting/blacklisting. Whitelist. Blacklist. Graylist. Network access control, NAC devices. Port address translation, PAT proxy firewall. Proxy types. Endpoint security. Module 11. Secure communications channels according to design. Module objectives. 1. Define secure communications channels that support remote access services and collaboration. Voice. Voice over Internet Protocol, VoIP Session Initiation Protocol, SIP quality issues. Packet loss. Jitter. Sequence errors. Multimedia collaboration. Peer-to-peer instant messaging. Internet Relay Chat, IRC. Remote Access Tunneling/VPNs. Virtual Private Network, VPN Layer 2 Tunneling Protocol, L2TP/IP Security, IPsec SSL/VPN. Case Network Security Incident Mitigation. Instructions. To accomplish the next exercise, we will work in small groups. Part I. Each person will briefly, 1 minute or less, relate a current event incident related to a lack of communication and network security of a system they are familiar with. The team should choose a single critical incident from the events related to use for Part 2. Part 2. The group will take the critical event and produce 2 or 3 threats executed on a vulnerability from the case and the appropriate countermeasure to mitigate it. Reference modules 2 to 9. Use the blank threat/countermeasure charts in your CBK guide. Module 12. Domain review. Domain summary. Solid understanding of the elements that comprise communication and network security coupled with an accurate measure of business needs leads to a meaningful approach to protection. Keeping abreast of ever-changing attack surfaces and continuous monitoring of emerging threats will enhance the approach to communication and network security. Domain review questions. A system user is sending an instruction from their source node to a destination node. The instruction tells the receiving station to create space for incoming fragments that are not equivalent to the actual fragment size. What is happening? A. A normal process of fragmentation. B. Anvil attack. C. Teardrop attack. D. Level attack. Answer. The correct answer is C. The teardrop attack exploits the fragmentation process at the destination station to place corrupt data into the fragmentation space. Domain review questions. At what layer of the Open Systems Interconnection, OSI, model does the Address Resolution Protocol, ARP, resolve? A. Layer 2 Data Link Layer. B. Layer 3 Network Layer. C. Layer 4 Transport Layer. D. Layer 5 Presentation Layer. Answer. The correct answer is A. ARP resolves IP addresses to MAC addresses at Layer 2. Domain review questions. A remote workstation is attempting to probe your workstation by means of port 79, finger. What is the minimum technology that can be used to block this incursion? A. Access Control List, ACLB. Dynamic Packet Filtering. C. Next Generation Firewall. D. Web Application Firewall. Answer. The correct answer is A. Access control lists define if an IP address or port can be allowed or denied into a network. Dynamic packet filtering and next-generation firewalls are beyond the minimum technology necessary to prevent the attack. Domain review questions. Which Lightweight Directory Access Protocol, LDAP, attribute defines a portion of a directory access protocol name that can resolve by Domain Name Service, DNS? A. Relative domain. B. Domain component. C. Organizational systems. D. Distinguished unit. Answer. The correct answer is B. A domain component is the only item that is an attribute of LDAP and that can be resolved by DNS. Domain review questions. You have inherited a version 1 Simple Network Management Protocol, SNMP system. What is the primary risk associated with utilizing this version? A. Unencrypted traffic. B. Routers rejecting GETs. C. Switches rejecting NOT. D. Connecting to systems without authentication. Answer. The correct answer is D. A rogue user can simply connect to an SNMP v1 system by means of a public or private community string without need for authentication. Domain review questions. A Smurf attack exploits the spoofed address of A. An attacker and an ICMP echo request. B. A victim and a UDP port 7 message. C. A victim and an ICMP echo request. D. A victim and an IGMP echo request. Answer. The correct answer is C. A Smurf attack is Internet Control Message Protocol, ICMP, echo requests sent to the network broadcast address of a spoofed victim, causing all nodes to respond to the victim with an echo reply. Domain review questions. A malicious insider has access to Workstation's host file and after pinging the website of www.124.com takes the IP address that is resolved and maps it with www.abs.com. What will happen when the user of the workstation attempts to resolve www.abs.com in their browser? A. No website will resolve. B. www.124.com will resolve. C. www.abs.com will resolve. D. None of the above. Answer. The correct answer is B. Mapping any IP address to any domain name in the host file will cause a workstation to resolve that IP address to that name in the workstation's browser. Domain review questions. How is distance vector different from linked state routing protocols? A. Distance vector uses a more complex algorithm than linked state. B. Linked state has a cost of 0 only. Distance vector has a cost of 1. C. Distance vector calculates cost based upon hop count. Linked state can use bandwidth. D. Distance vector can use bandwidth to calculate cost. Linked state uses hop count only. Answer. The correct answer is C. Distance vector calculates cost based upon hop count. Linked state can use bandwidth, availability congestion, and hop count. Domain review questions. Internet Group Management Protocol, IGMP, is used to A. Send unicast messages. B. Send multicast messages. C. Send broadcast messages. D. Send one-to-all messages. Answer. The correct answer is B. IGMP is a multicast protocol. Domain review questions. At what plane can you locate routers and switches in a software-defined network, SDN? A. Data link and network plane. B. Data plane. C. Control plane. D. Application plane. Answer. The correct answer is B. Routers and switches are in the data plane.
So, I hope you had a chance to tap all the way into this one. It was a long topic, but it's definitely necessary. Hacker Black, if y'all want to see more content like this, make sure y'all bang that bell icon. Make sure you like, subscribe, and share. And all of the hackers, all your hacker friends, all of your security practitioners, security professionals, make sure you're trying to make more money, that you understand these topics all the way. It's Hacker Black. Tap in.